This is section 4.7, Congruence Transformations. For our vocabulary, first of all, a transformation is an operation which maps a figure onto a new figure. Maps a figure onto a new figure. And we're going to take a look at these in just a minute, but for now, just to get the vocab out of the way, the pre-image is the original figure. And the image is the new figure. As far as congruence transformation, that's what we're going to be looking at in this section. These are rigid transformations. They're also called isometries, okay? And the thing that stays the same with these are their size and shape. But what's different is their position. So transformations, the rigid ones, their size and shape are the same, but their positions are different. So we're going to start off with looking at three different kinds of transformations: reflections, translations, and rotations. I like to remember these: F in reflections for flip, the S in translation for slide, and rotations has the word rotate in it, and that's what you're going to do with the figure. You're going to rotate it. So to look at a reflection, if we have this triangle here, and I've drawn one that's the same size and shape, pretty much so. If we flip it over a line, and in this case we have a vertical line, but if we flip it over the line, we have its reflection. So there is our pre-image. This is our new figure, our image, and they can be mapped onto each other. Now for a translation. Looking at this middle transformation here, I've gone ahead and I've drawn a triangle on top of that one so I get the same shape. Now if I would slide this triangle, like over to here or up to here, that's a translation. The triangle is of the same shape and size, it's just a different position. It's been slid to a new position. Lastly, we have a rotation. So I have my triangle here that's the same size. My image I copied onto this little piece of clear paper here. And so now if I rotate my figure, I have my image. And I arrived at that by rotating it. A couple of things about rotation. Rotation is usually rotated around a point, so let me draw in a point. This makes a difference in how the position of your new triangle will end up. But if I rotate it, I'm going to keep this point the same and just rotate my figure around, depending on how far I rotate it. Okay, so that's a rotation. It's a little off the page, but there it would end up. So we have reflections that are flipping a figure. We have translations which slide a figure, and rotations which rotate a figure around a point. Now for example 1. Let me move these little sheets here. we need to identify the congruence transformation that was completed on these figures. Our figure here in ink is our pre-image, and the figure here in pencil is our image. And what kind of translation was done here? Well, one way would be to take a sheet of paper, a clear plastic sheet of paper, and a magic marker, and trace over the pre-image. Nope, now my marker probably won't work. Yeah, it's not going to work now. There it goes. And then see what you would have to do to get it to map on to the image. And in this case, I think you can see that I just had to slide it on. Okay? So this figure, let me switch back to my pen. This figure has this point mapped onto this one, and like this point would map onto this point over here, and this point here maps onto that there. So this is a translation. If we look at our second figure here, we have this original triangle, and what kind of a transformation was done to end up with a triangle over here? Well, if I see how I'm having to turn my paper, I'm rotating my paper. So it's a rotation. This point was rotated around to here, and this point rotates around to there, so rotation. And lastly, let me copy my original figure here. And what am I going to have to do? What kind of translation am I going to have to do to have it map on to my new image? I'm going to have to flip it. So there we have a reflection. And back to my pen. Reflection. Okay, please complete Check Your Progress 1, all of them. For example 2, I found a picture, and from this picture I would like us to identify what kind of real-world transformation we have here. This is a bridge, and in the water here you see the railings and the arches, very faint. This is down in the water, this is the bridge itself. So our real-world transformation that occurred here is a reflection. And oftentimes you say, did you see that reflection in the water? Okay, and it just flipped the pre-image over to the image in the water. Complete all of the Check Your Progress number 2s. Example 3 is going to ask us to verify the congruence of our shapes after a transformation. So we are given two triangles, triangle PQR and triangle JKL, and a transformation has been performed on these. In particular, it's been probably JKL, I'm assuming, was the pre-image, and PQR is the image. And after this transformation, they're wondering if these figures are congruent. And in order to prove their congruency, what we can do is we can determine the lengths of the sides. And it should be that we have 3 sets of sides that are congruent. So maybe like KL is congruent to QR, and LJ is congruent to RP, and PQ is congruent to JK. And how we could do that is using that distance formula. So let's start off with finding the length of segment KL. So our distance formula is in this case going to be -3 plus 1, squaring that, plus our y coordinates, the difference there, so -5 plus 4, and squaring that. So -3 plus 1 is -2, squaring that is 4. -5 plus 1 is -5 plus 4 is -1, squaring that is 1. So we get a radical 5 here. For KL, for QR, we're going to have our x coordinates of 3 minus 5. Well, I'm going to run out of room here. Okay, I'm going to slide this figure to the left a little bit more, maybe. Okay, 3 minus 5 squared plus the y coordinate difference would be -3 plus 2. So we would have -2 squared, which would be 4, plus 1 again, which, yes, would be radical 5. So those two sides are congruent. If we look at LJ and LJ and then RP, LJ has x coordinates here of -1 minus 2, so we're going to have -1 plus 2, square that, and the y coordinates then would be -4 minus 0, and this would be, oops, got the square there, 1 squared plus -4 squared is 16, so that is radical 17. And then for RP, we have x coordinates of 5 and 4, so 5 minus 4, squaring that, plus our y coordinates of -2 minus 2, squaring that. We have 1 plus 4 squared is 16. Sorry, so we have radical 17 again. Now, JK, and our x coordinates here, -2 minus a 3, so we're going to write in -2 plus 3, squaring that, plus then our y coordinates are 0 and -5, so 0 plus 5, squaring that. We have 1 plus 25, which equals radical 26. And over here for PQ, our x coordinates are 4 minus 3, squaring that, plus our y coordinates, the difference there is 2 plus 3, so we have 1 squared plus 5 squared, which once again is radical 26. So we have 3 pairs of congruent sides. So we have looked at the congruence of our figures after the translation. So by side, 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 we have congruent triangles. We have triangle JKL is congruent to triangle PQR. Now complete Check Your Progress number 3.